Simulation video on guided versus wireless media network topology created using Cisco Packet Tracer. In this demonstration, we'll explore how wired and wireless communication differ in terms of connectivity, performance, and reliability within a computer network. By the end of this video, you will understand the key differences between guided and unguided transmission media and how these differences affect throughput, latency, and also the overall network performance. Now let us focus on guided media simulation. We'll first see the guided media uses physical cables such as twisted pair, coaxial, and also fiber optic cables to transmit data. Here we are using a standard fast Ethernet cables which are reliable and provide full duplex communication. Each wired device is assigned an IP address within the same subnet and the router is configured with its gateway address. Now we initiate a ping from the wired PC to the server. The packet tracer simulation shows that the packet travels to the switch and router with very low latency and no packet loss. The data transmission is fast and stable and demonstrating the efficiency of the guided communication. In Cisco Packet Tracer, from the end devices, drag two PCs, PC0 and PC1, and also a server from the network devices. You can drag a switch 0, connect PC0 to the switch 0 using copper straight cable, and PC1 to the switch 0 using copper straight through cable, and server 0 to the switch 0 using copper straight through cable. Assign IP address to all the PCs servers. PC0 has the IP address 192.168.1.2 and PC1 has 192.168.1.3, and also server 0 has IP address 192.168.1.1. And now let us test the connectivity. Open the PC0 command prompt and ping 192.168.1.1 on the server. If you get the successful reply, then the simulation is done. On the left side, we have guided or wired network which consists of two PCs and a server and also a switch and a router using Ethernet cables or fast Ethernet cables. This portion of network is backbone. It forms the internal local area network LAN before connecting to the router and then other networks like wireless LAN or internet. The components use the router that acts as a gateway between LAN, wireless LAN, and also the internet. The switch acts as a central connection point for wired devices. PCs are the end devices for the users within the LAN. The servers, which provides the local network services, the file sharing, testing, web services. The cables used for guided data transmission. All wired devices send and receive data via switch 1. The switch operates at layer 2, data link layer, and forwards frames using MAC address. The router connected through fast Ethernet router packets designed for other networks like wireless LAN and also internet. Communication within the LAN occurs directly through the switch, offering low latency and high reliability. The transmission medium, the copper cables carry electrical signals. The reliability is very stable and less prone to interference. The speed of data is very high, from 100 Mbps to 1 Gbps. The security, which is more secure since data travels through physical cables. Mobility is limited for the devices which are stationary. Error rate is very low due to minimal noise or interference. Advantages are high transmission speed, low latency and minimal packet loss, reliability and consistent performance, easy troubleshooting, provides stable backbone for the whole network. Now let us move on to the configuration of wireless router like SSID, security, DHCP, LAN IP. Click on the wireless router icon in Open its device window. Go to the config tab, the section in some packet tracer versions. Set basic wireless settings like SSID as wireless net, the mode or network type as default, and channel as default. You can leave this as default. Set security mode as WPA2 PSK or choose WPA2 if available, and passphrase or key as 12345. Set router IP address for wireless or LAN side under LAN or wireless interface settings. Set the router's IP address as 192.168.2.1 and also the subnet mask as 255.255.255.0. Enable DHCP so wireless clients get automatically active in the router window. Find DHCP section and turn on DHCP. Configure the DHCP pool, like example, start IP address 192.168.2.2. The end IP address is 192.168.2.100. The subnet mask is 255.255.255.0. Default gateway is 192.168.2.1 and also the DNS, which is optional, that is 8.8.8.8. Connect to other networks if needed. If this wireless router must link to another wide network, connect the router's WAN or Ethernet port to your network device using copper straight through cable and configure the other router's interface IP address or routing as required. For a standalone wireless network test, you do need not to connect to anything else. To connect laptop 0 to SSID, click on the laptop 0, choose the desktop tab, click PC wireless or wireless network config icon. A small wireless GUI opens. It will show available SSIDs. Select wireless net from the list. Click connect. A pop-up asks for security or passphrase. The type 12345. Click OK and connect. The laptop should show the connected status and display an IP address obtained via DHCP. If your laptop doesn't show SSID, make sure that the laptop's wireless adapter is present and enabled. To verify the IP assignment on laptop 0 in desktop, click on IP configuration. Still in laptop 0, you should see DHCP selected and an IP address 192.168.2.1 range. For example, the IP address is 192.168.2.2 and the subnet mask is 255.255.255.0 and the default gateway is 192.168.2.1. And in B, on the laptop 0, open command prompt and type ipconfig. The packet tracer's realistic prompt will show the IPv4 address. To test the wireless connectivity, ping the wireless router. From laptop 0 in the desktop command prompt, run ping 192.168.2.1. If you see request timed out, that is failure or troubleshooting, verify that the laptop 0 is actually connected to the wireless net and you enter the correct passphrase or key, and check DHCP on the wireless router which is on. Ensure the router's wireless radio or SSID is enabled and move the laptop closer to the router in the workspace. Reboot the laptop. You will notice a slightly higher delay compared to wireless setup. Wireless communication is subjected to interference, signal attenuation, and also shared bandwidth, which can increase latency and reduce throughput. The packet tracer may also allow packet collisions and retransmissions, representing real-world issues such as signal overlap or weak signal strength. Now, let us compare the performance between wireless and guided media. In wide network, the average throughput is much higher, up to 1000 Mbps or gigabit Ethernet. The latency remains below 2 milliseconds and the packet loss is virtually zero. In the wireless network, throughput depends on signal strength and also the distance. Under ideal conditions, 802.11n Wi-Fi can reach up to from 100 to 200 Mbps, but real-world performance is typically lower. Latency averages around 10 to 30 milliseconds with occasional packet loss due to the interference. These differences clearly show that while wireless offers flexibility and mobility, wired connections provide greater stability, reliability, and also the guided media offers high speed, low latency, and minimal interference, making it ideal for backbone connections and data-intensive environments. The wireless unguided media, while slower and more variable, provides mobility and convenience, especially in scenarios where cable is impractical. In modern networks, both technologies are often combined using wired links for stability and wireless access for flexibility. Thank you for watching this simulation of guided versus wireless media in a network topology using Cisco Packet Tracer. Don't forget to like, share,